such a thing. Hello.
That stage is small.
It is a small stage. Don't fall.
So welcome to our talk today. I am Scott Hunter. I'm the Director of Program Management at Microsoft on the .NET platform. And
I am Scott Hanselman, and I work for him. We wanted to get you a really cool Scott, but we couldn't because he's busy. So instead, we got you two lesser Scotts, and he went to the dollar store and got a red shirt.
what can I say? Okay, we have a lot to cover today. We have a lot of demos. I hope you want to see some demos. We always like to start with, .NET. When Scott and I joined Microsoft, you could build very few things in .NET. And today you can build desktop, web, cloud, mobile, gaming, IoT, and AI. And we're going to show almost every one of those workloads today in the talk. .NET Core 3 shipped about 5 or 6 weeks ago. We have over 1 million developers, .NET developers, that have moved to .NET Core already. One of the most exciting things to me is .NET Core 3. We're only about 5 to 6 weeks in, and almost 2/3 of our .NET Core developers are already using .NET Core 3, or at least trying it. So that's kind of the fastest adoption we've ever had for a .NET. Typically, a .NET takes years and years to adopt, and we're seeing with Core that it's weeks and months, not years.
And we'll see why it's so easy, because things like side-by-side installations is going to be a reason that people will be able to try it out.
We're open source. And we passed a threshold where we've taken over 100,000 PRs from the community in .NET, which is awesome. We've only been open source since 2014, so 100,000 in 5 years feels like a pretty good win. This is just a few of the customers that we have in .NET. We have a page on our site, .NET/customers, you can go to read some of the case studies on these. Some of the fun ones to talk about, UPS, if anybody has the UPS app, that's a Xamarin app that runs on iOS and Android. That's kind of a cool one. Setpoint Medical is a customer using Kubernetes with .NET Core for microservices. There's a ton of these. Light Sales doing some interesting stuff with our AI tech. But go check that page out. And then Stack Overflow. They just migrated to .NET Core 3 a couple weeks ago.
I just realized that the audio.
This is a mistake. We're going to switch.
We made a good mistake here.
Yeah.
So we've got a really cool video that we worked with Stack Overflow to show you. And earlier when they set up the audio, they said, "Do you have any audio with your presentation?" We said, "Of course we have audio." He brought lots of audio. Well, we plugged it into his laptop, and we're running the slides off of this other machine. So what he's going to do is he's going to switch the button, push 6, bloop, and you're going to pretend like this never happened, and we're going to fix it in post, like there's a post-production. And now he's going to hit next, and it's going to play a video, and you're going to be impressed.
StackOverflow.com is a Q&A site for engineers where anyone can go ask a question and anyone can go answer a question.
Stack Overflow functions from a pool of applications, and from the beginning, we've depended on .NET to drive all of our applications. And when we heard about the advancements in .NET Core, we were really excited at the idea. We've been working on porting our entire application over to .NET Core. One major place that we've seen improvement is performance. .NET Core 3.0 has allowed us to build a much faster application and get information to our users faster than before.
With .NET Core 3.0, we can build the app and run it on our Windows developers machines, our designers with Macs, and an enterprise in the cloud on Linux, and build it one way, and that's tremendous.
Right now we live on our own servers in different areas throughout the country, and something we've always wanted to do is be able to use the cloud, and .NET Core allows us to do that. Azure is the best cloud platform for hosting .NET.
Cloud deploys are also much simpler because there's just far fewer moving pieces for us to manage and deploy when we do upgrades.
Right now, Stack Overflow's application exists as a large application, and through .NET Core 3.0, we can add more modularity to different sections of the application. So that allows us to host the different modules in different areas, which allows us to experiment with things like Kubernetes and Docker.
.NET Core 3.0 lets us run any container. This lets us ship an appliance to enterprise customers, dramatically lowering our support costs and making it easier to onboard customers. We can take a few of our auxiliary applications and just make them middleware, which means fewer apps to deploy and fewer apps to manage. It's the testability that really draws us to .NET Core. We can test a method end-to-end, server, client, do things we could never do before in the old system. .NET Core being open source and on GitHub is very empowering to the community. We can find and fix issues and make suggestions for the benefit of everybody.
It's amazing to be a part of the .NET Foundation. What the .NET Foundation is here to do is support .NET developers throughout the world.
With .NET Core, I'm just not fighting all of the meta of building software. We can actually just go build the software.
Cool.
Cool.
All right, switch back to 5. 1, 2, 3, go.
Cool.
You have to skip past the video now.
Okay, so we just shipped .NET Core 3 about 5 weeks ago, and if you know anything about .NET Core 3, we have what we call fast deployments, and we have LTS, long-term support. The long-term support version of .NET Core will be out the first couple of days of December, along with Visual Studio 16.4 and Visual Studio for Mac 8.4. .NET Core 3 brought a bunch of new workloads to .NET Core. It brought desktop development. It's got full stack web with Blazor. And of course, we have the same type of side-by-side stuff we've had in .NET Core all along, but we brought that to the desktop, and some new features with C#8. And we're going to talk about many of those things today. Microservices is a big term. In fact, Scott and I were just saying before, we should have put microservices in the title of our talk today. We hear a lot of interest in talking to customers around microservices, primarily when they want to take a big monolithic application and break it into 2 or 3 pieces they can iterate on at a faster rate of speed. And this is something that .NET Core is awesome for. As I said before, you can do independent deployments, so you can have your teams kind of work in parallel instead of actually working on a single thing. By breaking your app up into some pieces, you can also scale some of those pieces more independently. And of course, with those broken up pieces, you have smaller, more focused teams. We obviously have great technologies inside of Azure to run microservices, Kubernetes, which will manage your apps. In fact, the app we're going to build today does run in Kubernetes, and it's pretty cool. When I was building the app, I didn't ever add HTTPS to my app, but I just deployed it up to Kubernetes, and it did all that for me. So there's a whole bunch of things that Kubernetes will actually manage for you once you get the app running up there. We added a bunch of tech in ASP.NET Core 3 to work around the microservice space. One is gRPC. So we've had ASP.NET Web API for many, many years for doing REST, but we've had a lot of feedback from our customers saying they like the strongly typed contracts that they might have used in WCF in the past. And so instead of bringing WCF back, we brought gRPC. And we did that because gRPC is actually not just a .NET technology. It works in Java, it works in Node, it works in Go, it works in C++, it works in a ton of stuff. And so you can build a gRPC server in .NET and call it from any other language. And vice versa, you can actually take a gRPC server written by some other team in your organization and call it from .NET. The second thing is ASP.NET is traditionally focused on producing HTML. Mm-hmm. All of our app types minus Web API produce some form of HTML. And our customers have asked, if I'm building a service for like a microservice, how do I build that? And so we have a new template called a worker service, which is for long-running apps that might do something like listen to a queue or call some API and cache it so it can be called from something else. And so that's now first class, and it brings all of the ASP.NET and .NET Core things to it: logging, configuration, dependency injection. And we've also, in the same space, we've added support for Identity Server and Web API to make it easier to actually put authentication in front of your APIs. And with that, how about we do a demo of
Sure.
Worker Service? And
It took you 8 minutes and 30 seconds to get to a demo. That's not bad.
We'll get back to that later today.
Yeah, you think so?
Actually, you don't need this. You need
All right, you do
your
it.
laptop.
Well, no, you're going to do it.
You're doing a Worker
Am
Service.
I doing it?
Yes, you
Oh,
are.
All right. Glad that we planned that ahead of time.
An hour and a half ago.
Did we?
Yes.
I don't remember walking through that. All right, I'm going to say File New Project. And
As
when
he has the Worker Service on his machine.
are you saying that we did that earlier?
Yes.
Well, we're going to make Worker Service 2. Worker. This is how we usually talk. Sometimes there'll be feedback in the thing where you like type in, like, are they mean to each other? Yes, all the time. I'm going to go and create another Worker Service. And this is a template that is set up specifically for what that means is a worker service, not a console app, not a web app. It's somewhere in between those two things. So if we go and look at, by default, there in the program.cs, we've got this idea of a hosted service, specifically worker right there. Now, if we take a look at worker and what worker does, notice that it is deriving from background service. And background service has this async execute method. And what's interesting about it is all of the kind of stuff that you don't get when you make a console app, that dependency injection where you're like, ooh, I want some config, and I want some logging, and I want some this, and I want some that, you would ordinarily have to go and say, I want all of ASP.NET. And it's like, imagine a slider bar from empty to console app to ASP.NET empty app, and then you start getting into MVC and Razor Pages and routing. We want to make sure that you have a very gradient slider bar. You know those slider bars that they look like a slider bar, and then you pull it and it goes snap, and there's only 2 options? That's not a slider bar, that's a checkbox. We want to have lots of different moments there. So ASP.NET Core is allowing us to do that. So in this case here, we get the lightweight worker service with the dependency injection and the benefits that you would normally get from ASP.NET. So what is it you want me to do, sir?
So now let's go back to me and let's talk about, well, actually, one quick thing on this.
Yeah,
how about we go into the NuGet package manager?
Yeah, let's do that.
One of the cool things about the worker service is, what if you want to build a real service, like a Windows service? How hard would that be to do? You can just go add a NuGet package, add 1 line of code to your application, and it becomes a Windows service.
So we've got extensions in this namespace, this Microsoft.extensions, and you can go and say, I want to do this or I want to do that. And if I say .windows, let's see if my internet holds up here. Oops. .windows. Which one was that?
You want Windows Service is what you want.
Windows
you want Microsoft
service.
extensions hosting.windows service.
Okay, Windows service. I don't think that's what you want.
Do the Google in, but it's.
I'm going to Google with Bing. What's wrong with you? No.
There's also a hosting.systemd as well, so there's 2 of those there.
Hosting.systemd. Not finding that either, brother. We're going to go, oh, there it is. Hang on. What? There you go. So there's different kinds of background services. Let's think about that for a second. So .NET Core is cross-platform. Now, I can't go and just say, I want a background service, because at some point, some actual thing in the operating system has to do the work, right? Windows has the notion of Windows services. On Linux, you might have systemd or other ways to go and host a service. So what we've got here are packages that are extensions. So you're portable, you write all your portable code, and then you go and say, all right, I'm going to run on Linux, and I'll use systemd. And then you say, I'm going to run on Windows, I'll be a Windows service. All the code is still portable, but that one moment as you go from being abstract to being concrete, you go and say services.use systemd, you bring in that, and then you say services.add Windows service. And what's cool about that is that these have been written such that they no-op if they're on the wrong thing. So if you go and create a worker service and say, I want it to run in a background on Linux and I want it to run in a background on Windows, it's 2 lines of code, add systemd, add worker, add Windows service, and it just works in both places.
Yeah, copy it to Linux, and it's a systemd service. Copy it to Windows, it can be a Windows service.
That's super cool.
That's simple.
Switching to 6.
So let's go back and look at a more complicated real service. So all the code I'm going to show today, you can download from GitHub. I'll show the link afterwards. And so Scott showed a worker service that doesn't do a lot. So let's look at a real service and think about how we might build a real service in the real world. As Scott mentioned, these services use all the features we've had in .NET Core and ASP.NET. So you're going to notice here I've got a logger, I've got configuration, I've got a client factory, I've got a memory cache.
See how he pulls in that memory cache. Imagine making a console app and then being able to just go and boom, I pull in a memory cache. Just happening automatically. And nothing there is not an interface, right? It's I this and I that. They just get injected in on line 25.
Yes. And this, once again, it sits in a loop. And what this is going to do is it's going to go out and call AccuWeather and pull their weather from AccuWeather. If you've ever tried using any of these weather services, they all want you to pay money for them. And so what they are is they're rate limited. You can only call them X number of times per day before you run out of attempts. And so what we thought we would do here is have our worker call out, get the weather, stick it in a memory cache, and then wait a while, and then call it again. And you can see this loop here. It's got a client factory. It calls the weather URI endpoint. It gets the data back, and it sticks it in the cache. And then it waits a while, and it calls again. This is a service. It sits there and does this in the background all the time. Now, that by itself, not so exciting. I need more. So I want to be able to call this from either a REST endpoint or from a gRPC endpoint. So I need to add those to my project. And so you'll notice I have this folder called protos. And inside of this, I've got this weather.proto. You want to describe that, Scott?
This is really important because the first time you look at this, you're like, oh, that's kind of C#y. It's not. It's a proto file. It is agnostic. It is platform and language agnostic. That's kind of like if you're a web services person who's somewhat old, like myself, that's like a WSDL file. It's a description. It is an IDL file if you're even older than that, right? This is an interface definition, but it's a .proto. And when you're doing any kind of RPC, you need that strongly typed prototype that will then be used to generate your client and your server.
Right. And so we have tooling, of course. We are the tooling company. If I go over here and I do add, and I go to add service references, you're going to see that, waiting for IntelliSense to start loading.
You can continue working.
Not on what I want to show you, but I can continue working.
Not a fan of that. What does that even mean?
While that's waiting, I don't know what it means. But anyways, while we're waiting for that to happen, or if it ever happens.
If only we knew someone in power at the company.
Yes.
That's what you get for installing a daily build last night.
So what actually happens here is if I right-click on that and add service references, I can add a gRPC server or client. And in my case, I've added a server. And you can tell that I've done that. If I go to my CS_proj file, look here. Here's the line that tooling would have added. It basically says, include that weather.proto file and create a server for me. And I'm going to go to my services folder here. And inside of my services folder, I've got a weather service. And you're going to notice that it derives from weather.weatherbase. And if I have 12 into that, you'll see a bunch of stuff you don't want to see. But it generates all this gobbledygook for me that I don't want to deal with. All I have to do as part of my service is implement the methods. And so in here, there's two methods to implement. I've got a get weather stream. Notice my override. And I've got a get weather with an override. So
let's pause for a second. That idea, he had to do two overrides. So it generated the base class with the do weather and the other one, and then he just has to override the ones that he wants to implement. The other one would remain unimplemented, and I'll just take a very brief second and switch over to 8 because I want to show you what the dialog box does in fact look like. You right-click, you say Add Connected Service. You can do an Open API or a gRPC one, and you notice here at the bottom, select the type of class to be generated. In that case, it could be either the client or the server.
So you're going to notice here, I implement those two methods, and I do exactly what you think I would do. I go get something from the cache, I grab it, and I stick it and return it using strong types, because this is gRPC, strong types. So you might ask, we're the .NET team. Our job is to make people productive. And so once we do this, how hard is it to generate a client?
Okay.
I need to make a client. So let's go back to another version of Visual Studio here I've got here. And it's basically a plain, boring console application. And we're going to try that dialog again.
Dun, dun, dun.
Service reference.
Pressure's on.
It comes up. And notice that I have two options. These are both brand new in .NET Core 3. I have Open API and I have gRPC. So our customers told us they loved, as you said, the way that we could just generate clients for you. So my service, let's show something over back in the other VS real quick, Scott. Check this out. So we have a proto file. We showed that. And we talked about microservices a little bit. Take a look at this code, Scott.
Okay. Where are we looking?
So down here, notice that I have an endpoint. See that?
All right. Let's.
So I didn't build a controller. I didn't build any other tech, because we want to say that .NET Core can be microservicey. There's no ASP.NET there. I took an endpoint, whack proto, and I just basically said when this is called, run this C#, and in this particular case, send a file out.
So what he's doing there is he's making a well-known location for someone to go and get that. So if you're making a weather service and you make that little worker service and everyone knows you go to /proto to get that information, then the client will be able to go and say, not load the file up off of disk, but say, oh yeah, just go to weatherservice.scotthunter/proto, downloads it, grabs it, and you beat me to it.
So I did that because what I want to do is I want to be able to go over to that tooling and give it that proto file. Just give it the URL there. I press OK. And we're going to go out and get all the gRPC NuGet packages, and we're going to download that proto file for you, and we're going to stick it in your application. You can see there, there's that proto file. It went and grabbed for me automatically. And if I double click on this, once again, you can see all the...
Now notice how this says line 6 and then line 95, and then it has a region where it's like, don't look here. But he's going to look there, aren't you? You looked anyway,
yeah, you don't want to see any of this stuff.
But what that is, and this is important because we are saying don't look there, but of course it was one click to look at it. Nothing's hidden. This is not the Microsoft of black boxes where it's like, here's a thing, trust me, it's a DLL, and it does everything that you need to do. The code that is generated is something that you can see and understand if you choose to, but those are the base classes that he can then derive from. And now he automatically has strongly typed because gRPC, that RPC is remote procedure call. It's different than using a REST API, and in this case, he's got strongly typed stuff, and he's typing, and he's going to hit whatever dot. I'm watching. This is exciting to watch managers type, isn't it, everyone? And look, see, he's getting IntelliSense, and he can even get that little bit of documentation as well.
As I need to write gRPC code. So I newed up a URL, simple. I made a client, and now all I've got to do is call that client.
Cool. He types with his pinkies, just like this. It's fascinating to watch. It's very effective.
You'll notice this is kind of an oddity about gRPC is every method requires a parameter, even if the parameter is empty.
Really?
So you're going to notice here I've got to call google.protobuf.wellknowntypes.empty.
Now, certainly you could go and do a using and hide that and then alias it to something that's not quite as intense.
And you actually have to new that up. At that point, I've called the weather, and I can basically take this and say, yes, I will fix that, sir. Feel better? Okay. Now I can come over here and just say weather.temperature. And so you see how many 3 lines of code. We generated all the stuff for you, and you can just call these strong types, run it, and it exceptions.
What network? Is the app still running? You have to have the app still running.
It's amazing how fast that crashed. This is high-performance.NET Core.
You can crash faster than ever.
The problem is there is not a local host here.
No one wanted to say anything. You also need 2 slashes.
And let's move the slashes back where they go.
My review is next week. Thank you for that gift.
And amazingly, the tech works. But I say, when the URL is wrong, it fails really well. And so that shows you how fast we can build the tooling for you for this stuff. The client, if I wanted to build a REST endpoint, it literally is the same kind of steps again. I can go back over here and say add service reference, and there's this open API. And let's go back to the app and look about and talk about that. So if I look at my app also uses a couple of different NuGet packages. Let's go over here, and you can see I've got Swashbuckle in my application here. And what Swashbuckle is, it's a third-party NuGet package that generates something called Swagger. And if you look at my app, in a couple places in here, I've got some more code. You can see here's my use Swagger and use Swagger UI, and it gives me this fancy endpoint. Let's go grab that.
So just like gRPC has Proto, REST has Swagger or open APIs, Swashbuckle is the .NET client to go and consume those things. In the old days, we named things like web services description language. But now we call them things like Swagger. And that's fine.
We didn't name it.
I know. We, the young people.
But you can see I called this in the browser. Once again, I can take that same endpoint.
Exactly.
And I can go back to that other console application. I can give it a URL. And I can say OK. And it will do the same thing. It's going to go out, add the right NuGet packages to consume that from REST. And it's going to go grab that Swagger. You can see my endpoint is here.
Bingo.
And the same kind of thing. I can double click in this code, and you'll see all of the...
And as with all things, even though this is tooling in the back end, this is also something that you could do yourself. You can do it manually. You can do it from the command line. And when this goes and generates that, tools, when you have that descriptive language that expresses a web service, tools can go and show a UI. So you can get free documentation. The Swashbuckle NuGet package is fantastic for Swagger, and also it creates Swagger UI, which is documenting, and then Azure's app service can then express that for you as well. You're going to do something cool?
No, it's something really cool.
Okay. No pressure. We're all watching. No.
Oh,
You
come
do it.
on.
No.
Show me the skills, Mr. Hanselman.
No.
I think this is a weather dot,
Yep.
weather dot, weather client.
So weather.
And it's going to want an endpoint again, which I'm going to just steal this time.
Copy
And
paste
do
will
it the
never
wrong
be a
way.
problem at all.
I can steal that weather past the HTTP,
Yeah.
and now I have a rich weather client that I can basically call the same way we did the other one as well.
You sure about that? So weather client, you got one of those little nubbins here. I don't know how to do that.
There's a mouse right there.
Is that what that is? See how you've got this? This is still gRPC channel. You trying to call an open API?
Where's the gRPC channel?
If I hover over that, you're still in gRPC core channel base?
I am.
Because your namespace is
I have
weather.weather.weather.
too many namespaces.
It'd be like weather rest and weather gRPC.
Let's go find this thing.
Just spitballing.
You're right. Actually, the audience is spot on.
You get a taco.
You get a free mouse afterwards if you come up here. So
You never liked that mouse. You're gonna get the mouse that he never liked, because he's still using the little eraser thing on the ThinkPad.
and then once again, you can actually just call call stuff right off a client here.
Time check, 48 minutes.
Yeah, I know. JCK-san, you're good to there. I might hand the keyboard to Hanselman for a second and see if he wants
yes.
to.
Help me.
Another cool thing that we did as part of this is .NET tool-g list. You want to talk about what these are, Scott?
List-G.
You're right. See, I give him the keyboard. You want to take it?
No, I know.
So
I'm
explain what
afraid
those are.
because you're putting the pressure on me. I'm also going to do that. What? Oh my God. So there are .NET Global tools, and .NET Global tools are a lot like when you do like an NPM package and you go install global, and it makes things available to you. See that command on the right-hand side? Things like Entity Framework, you have a global tool for going and talking to databases and generating things. We've created an HTTP REPL. You see that fourth one there that says .NET HTTP REPL. So when you go and say HTTP REPL, in this case localhost, you go into this world. Check this out. This is kind of like we've changed directories into our web service.
Yes.
So I can go and help. I never know if it's help or if it's ls.
It's
Look at
ls.
that. It's ls. It should be DRR. We're like DOS people though, right? So then I can go like that and do a get. So I can wander around and explore my HTTP REST service. I can call it, I can make gets and post entirely from the command line, and then build up a script and then run that script against the stuff, which is really, really cool.
Yeah, I moved into JSON and I ran the get in the JSON folder. And I did that because the whole HTTP REPL came out of us trying to find a way to make it where you could control F5 a web API. We want to be able to actually let you debug APIs.
So if you think about that, like you've made a web API, and then what do you end up doing? You end up opening up a browser, and then you can do gets really easily, but then posts are a hassle. So then someone says, oh, just install, and then they give you a list of Postman or a half dozen other things. Here, you've got a built-in thing, and you can set the HTTP REPL as a browser, control F5 or F5, and then you're immediately debugging your web service. And it's very comfortable at the command line. Cool.
So something else we could show is, once we have that service running, we showed you can build clients from console applications. What about real clients? So I've got a WinForm app here. It's a .NET Core WinForm app, and I can go look at the form, and you're going to show a slightly different version of the code that I showed before. Here's my channel. Here's my client. In this particular case, I call a new method here called getWeatherStream.
And that's really important because gRPC isn't just a matter of going out and saying, make a get call. It's a streaming protocol. So he's saying, I want to basically open a connection to this, and I want updates.
Right. And so this is kind of cool because I can, if I go back and look at the service really quick, inside of the services under weather service, you're going to notice that one of these just sits in a loop. While I'm not canceled, go get something from the cache, send it out, and do that forever with a 2-second delay in it. It's one of the cool parts of gRPC, as you said, is the streaming ability. We're using a new C# feature here where I can take a for each, do a read all async, and do an await on the for each. That's new.
Okay.
That's new. So let's run the app.
People don't realize how those little things take away a whole lot of boilerplate nonsense as you think about what thread you're on and whether you want to do background stuff. All this work to do simple background processing in a Windows Forms app just fade away.
So here's the app. It's a WinForm.NET Core application. And let's do something kind of interesting, Scott. We talked about, we should actually go back to slides because we're missing stuff.
Okay.
Are we 5?
Slides is 5. There you go.
Thank you. So we talked about C# just a second ago. There's a whole bunch of new stuff in C# 8. One is nullable and nullable references. And this is a new feature we have with the compiler where the compiler can actually tell you whether you've made null checks. And this is fun to actually implement at Microsoft. I know Emo on the team, they spent weeks making the BCL check for nulls in all the right places when we first turned this on.
The base class library.
Yes. This will take years for it to actually get all the way to everybody because even though we've done it in .NET Core and the BCL, we have to wait for all those third-party NuGet packages to do this as well. But it'll be something you can try in your code, but some of the third-party references won't support it yet. That'll take a bit of time. Modern, we just showed the new support for IEnumerable, async IEnumerable. That allows you to take something that was an IEnumerable and use it with async.
Translating IEnumerable, all that kind of stuff. Being able to go and do a for loop like that in a non-blocking way.
In a non-blocking way,
there you go.
Doing async calls. And there's a bunch of other cool stuff with patterns. And one of my favorite ones is the one we call out here, which is the indexes and ranges, where if I want to pass an array to something, maybe you wanted to get the last 3 elements of an array, so you would do like
length minus
length
1
minus
and all that.
1,
And now you
and
can go just 1 ... and get a range and say I want to go from 3 to the end.
And that's some of the C# stuff that's here. Mads Torgerson from the team is around in the booth this week if you want to see him. He's the language architect for C#. Go meet him, please.
And if you go check out the docs at docs.microsoft.com and search for new C# features, you can actually see a nice list of, a lot of people don't realize C# is versioned. So you can go back to previous versions, version 6, version 7, and now version 8 with demos of everything.
We have that exact web page in the booth on the floor, and the team is showing all the features across all those. Our C# 8 demo was the async on the await, on the for each, showing you it's like one word, that's it.
So you jump over to Windows desktop apps, and there's something that's so interesting about that. If you wouldn't mind going here, that slide right there, my dad called me a couple of weeks ago, and he says, I need to install .NET. And I was like, oh, you care about my job. And I said, why do you want to install .NET? And he says, well, I need to get this thing called paint.NET, and it says I need to install .NET to get it. What is that? That idea that you have to go and install a thing to get to the thing that you want, that idea that you also, when you install it, might be changing the version or the state of the machine itself. Well, I've got .NET 4.0, and well, I want to use .NET 4.7. That is the challenge and the strength of .NET Framework today, is that it is everywhere. It's on 1.5 billion machines, but also we don't want to break it. So how do we give people the power to do interesting and cool stuff, but also make self-contained apps? We want deployment flexibility. That side-by-side deployment is so important. He's got a WinForms app, and you might say, oh, WinForms is old. We've got a whole team doing amazing, cool stuff to make sure that WinForms looks great on high DPI machines. It looks great on Windows 10. It has light-up features. So you have access to all the Windows 10 APIs and modern APIs within WPF and WinForms. Everything has been open sourced. In case you hadn't heard, WPF and WinForms themselves are in fact open source and on GitHub. And when you go and use .NET, when you basically do a brain transplant, you take your WinForms or WPF app, you remove their dependency on the .NET Framework, which is on Windows. You then pull it into .NET Core. Your app now becomes self-contained and can run anywhere that even if it doesn't have .NET on it. So any Windows machine, I could put a WinForms or WPF app on a USB key and then plug it in and run it. So what he's going to do, and look at his CS proj here, and what have you set up?
So I've added.
You were actually already on that.
Was I already?
Yeah, you were showing it already.
All right, great.
6.
I know.
Okay. So look at lines 10 and 11 there. So he's got publish, single file, and then of course runtime identifier. He has to tell the compiler where it's going to run, right? This runs only on Windows, and he's saying in this case it's going to be x64,
Yeah.
right? So what you want is your
Explain
own.
why that is. You have to tell it that because you can't make a single exe that's both a 32-bit and a 64-bit and an ARM at the same
Right.
time.
You have to pick one.
You have to pick something.
Right. But what's interesting about it is that you want a .NET that's private to your application. He's going to get his own version of .NET Core. So he's saying publish private single exe. You're going to go and do the publish gesture.
Yep.
Did you do that?
Let's do that.
I've been like, this might seem like a small thing, but I've been dreaming about the ability to do this for a very, very long time, to just give someone scott.exe and just have it run. When in the past, we have to go and install .NET and reboot and make sure that it's the right version and da-da-da-da-da. So he can do this from the publish dialog. He's gone and done it. Now look at this. He's going to go into the bin folder of his application.
Actually, easiest to do it right here.
Yep. So he's going to say open folder in File Explorer and then go up, down bin, yada, yada, yada. Make a release mode, core app, Win64. Goes into the publish folder. Zoom in on that. That is a Windows Forms app. It's 150 megs, and that's it. Now, hang on. 150 megs? That's a lot, Scott. Why isn't it 3K? Well, it's got all of .NET Core there, right? Now, that's a lot, but honestly, you can joke about 150 megs. You know that the PNG on your company's brochureware website is a heck of a lot bigger than 150 megs. So, I mean, the homepage of The Verge is at least a gig, right? So, what if, though, he took those dependencies and he gave them a good shake? Imagine a tree of dependencies. Flip it on its side. You're holding the trunk of the tree and you've got all the leaves. And you say, you know, I shipped system.xml, but I don't really need it. Give it a good hard shake and it falls off the bottom. We're going to publish a trimmed or a tree-shaken, trimmed version of this, and we only ship the assemblies that we need. We only ship the methods that we need. Now, this is something that's experimental right now, because if you were loading a DLL that was dynamically loaded, you'd have to go and list that out. Or if some part of the tree got trimmed off you didn't want to, you'd have to make a list of exceptions. You can say, well, I actually do use that. But the idea is then you do a publish again, and how big is your file?
It's publishing. This one takes a little bit of time.
Oh, because it's shaking the tree.
It's shaking
right?
the tree.
It takes
It's
time.
analyzing things. And remember that was 158 megs or so before.
Now again, that's not big. A lot of you have a lot bigger apps, so you can tease us, but you know we're right. With your 2 gig forms over data application. Now it's down to 90 megs, so under 100 megs, and we've got our Windows Forms app. Now keep in mind that the app itself, go back up to the app itself if you wouldn't mind. Go up outside into bin debug. So right there, and then down 1. Where's the executable itself? You can sort by type. The app itself is 166K, okay? And now that you've got that about 90 megs or about 100 megs space there, the app is only going to get so big. So your apps now, even if he added a whole bunch of functionality, that app functionality is not going to bloat up into hundreds of megs. So you have a really nice sized single executable that you can go and deploy on any Windows machine, and it's going to work really, really great. Imagine taking your existing applications, and then, by the way, any new apps that you're doing, you need to be on .NET Core 3. Like, you shouldn't be doing new development without using these features.
This is an older demo we wrote a couple years ago, but it's still very valid about another reason why you might want to move to Core.
Looks like you have 2 apps there, left and right.
I've got a .NET Framework one on the left, and I've got a .NET Core one on the right.
Okay.
And all this does is looks at my source folder on my hard drive, makes a pretty pie chart of it, and shows you how long it took us to iterate those files.
All right.
So it took about 2 seconds for the .NET Framework app to do that. Let's go run
So that's the exact same app, except a different runtime, right? There were multiple .NETs here, and .NET Core is on the right. Is it already done?
It's done.
Do I read into the coloring of it? You're colorblind, so you don't know what that is. It's just a big gray circle.
All I know is 655 milliseconds versus 2022 milliseconds.
That's all you need to know. So in that case, it was over twice as fast, and that's the benefit. So by just swapping out for this newer runtime, you're going to get those benefits, and we anticipate that it will only get faster. And you didn't make any code changes, which is significant.
Exact same code.
So he
between
could
both
have
apps.
used some of the new C# features, things like span of T for memory management, and it could theoretically get even faster.
But we did not.
All right.
So what you'll find in .NET Core is you'll find networking, file access, memory are all going to be much faster and much smaller than they were before.
And that is .NET Core 3 WinForms.
So I think.
So
Xamarin's
moving on
next.
to Xamarin.
I'll let you
So
talk to
the
that for a
ability
second.
to go and have an application run anywhere means literally anywhere. Now, some of my friends out there are green bubble people. I'm looking at y'all. But Scott Hunter and I are Team iPhone, and we're blue bubble people. We're better. And, but we want to be inclusive, because the opposite of inclusive is exclusive. I want my green bubble people and my blue bubble people to all have the ability to write their applications with C#. So Xamarin lets you do that, writing both native performance applications for Android and iOS. But in the past, it's been a little bit confusing how to do that, and you have to go and rebuild the whole app and then deploy it again. You have to get different emulators. It can be confusing. Now, what he's doing,
Well, you might have to have a Mac.
oh, you do need a Mac. So you need a PC, you need a Mac, you need Visual Studio, you need your phone. The ability to go and put together one of these applications has been non-trivially difficult, especially if you're just messing around and you're trying to get some application to work. And in the past, even just getting the Mac, I had to go on Craigslist. I got a Mac Mini and I put it under my desk, and then Visual Studio does the work, and then the Mac does the build, and there's this inner loop. The goal here is to make the developer's inner loop shorter. You make a change, you see the change. You make a change, you test the change. And then later, you build it on a Mac and you put it in the App Store. But why does the inner loop have to be as big as publishing out to the store? Well, Xamarin allows you to make that inner loop really, really short. We have no Macs on the stage right now. We have your personal iPhone. And I don't think that you can get anything like this working.
But don't. Let me get everything booted
No?
up here.
You think so?
I got to get my iPhone hooked up
I'm going to make
over
a
here.
challenge, and he's not willing to take the challenge. So I was talking to Hunter earlier, and I thought that because you need to get a cert, you need to get the Mac, you need to, provision your IDs, all the different stuff that you have to do. I was challenging to see if he could get an iPhone app running in a minute. Right. What could go wrong? It'll be fine. I love that you chuckled with the kind of confidence of like, it's about, it could happen, it might not happen.
In the past, as Scott said, you have to have a Mac. You might have to go put your phone into developer mode and all those kinds of things.
I made this slide for you. Have you seen this?
I have not seen this.
It's in PowerPoint, but it's got a little animation. So do you think you can get this running in a minute?
I think I can do it under a minute.
All right. So I'm going to hit that. I'm going to switch back. Look, it even goes like that. Click. Okay, 57. I'm watching the timer. I'm judging you.
Okay.
Ooh, look at you with the screen mirroring.
Uploading
true?
application to my phone.
Wait a second. There's no Mac, though. How are you uploading your application to the phone?
I see a Xamarin icon on my phone here. I'm going to click it. Press OK over here.
Okay.
Weather
Nice.
on my iPhone
27
from a
seconds.
Xamarin app in under a minute.
Nicely done, sir.
Is this awesome or what? No developer junk, no pre-installed stuff on the phone. The phone is just my phone plugged into a USB port on my computer.
So with the power of open source, what they're doing is they're taking some of the power of Mono and Xamarin and those technologies, and they're making that Xamarin player happen on the phone there. So he's actually pushing just the stuff that the phone needs. We've got a side-loaded IPA, and then it runs inside of that player. That's going to get even better very, very soon with a thing called Hot Reload, which will allow you to actually have your phone connected to your PC, make a change to your XAML, and see the change happen on your phone, which is going to be pretty freaking sweet. Nicely done. I had low expectations.
Yeah, the cool thing about that is, normally even on an Android device with a PC, you might wait for a minute while it copies all the DLLs and all the stuff up to the device. In this particular case with the hot restart, hot reload, what we're actually doing is just once you put the app to the device the first time, we look at the diff of the code and only send the diff across when you make a change, which means the payload to the phone is really small and the app can restart really, really fast.
Did you just pull a Mac out of thin air?
I pulled a Mac
Where'd
out
that
of
Mac come out? I said there were no Macs here, and this Mac just came out from
Yeah,
underneath. It came out from underneath another laptop. It was hiding under another machine. Is that 7? Do you want to switch to 7?
Let's go to the slides first.
All right. These slides?
Yeah, I'll let you talk to these slides.
I did that already.
Talk to the next slides.
These slides?
Yes, these slides.
On a Mac?
What is a Blazor?
Okay. Well, he's shocking me with his script changes and stuff. This is so fascinating. He's always trying to keep me on my toes. So web apps with Blazor. We call this full stack web development with C#. It is cool to know Angular and Vue and React, and I think it's great. This is not any disrespect to our friends in the JavaScript community, but there are a lot of people out there that know C# and they know C# really well, and they also have a lot of existing code in C#. They want to go and create an application that is like a Windows Forms or a WPF application, but they want it to run anywhere and they want it to run on the web. So what Blazor is it is an application development style that lets you do everything full stack, client to server, entirely in C#. So if you hearken back to when we were doing web forms, sometimes people tease about web forms, they joke about it because it's an older technology now, over 10 years old. But what was web forms' job? Web forms' job was to hide the complexities of the web from you. Specifically, web forms put an event API on top of HTTP. Web forms was stateful when the internet itself was stateless. Now we've embraced things like REST. We've got ASP.NET Core, which has things like an MVC pattern, and we have the ability to do that, but it's still hard to do things like text boxes over data, because everyone's got a big complicated form. Well, React and Vue and Angular go and remove the complexities of the internet. They are themselves abstractions on top of that in order to make a more stateful environment. But they require you to understand those technologies. So could one create a strongly typed C# application that shared code with both the client and the server and still ran on all browsers? That's the kind of the idea behind Blazor. Right now there's two things. There is Blazor on the server and Blazor on the client. So imagine if you have your application start up. It is a web application. This is not like Silverlight. This is just HTML. It's entirely open source and entirely on open web standards. Then it makes a persistent connection back to the server and runs C# on the server. So as changes are made on the client, we're conversing with the server. So we have Blazor components running on the server. And then coming in spring of next year, what if you moved that C# and ran it in WebAssembly entirely on the client? You would actually have no plugin, no code transpilation. You would have C# running in the browser itself. You want to switch over?
Yeah, I thought we'd show something new today. We've been shipping Blazor previews for a while.
Yep.
And it RTM'd with .NET Core 3. And
it is out and ready to be used today.
And Visual Studio 2019 16.3,
Yes, sir.
It is. But we've had a lot of feedback that people that they're building on a Mac would like to actually do it on a Mac.
Ooh.
And so for the first time ever, I'm going to show you what you can do today. If you have VS for Mac installed on your machine, there's always this check for updates. And it will bring this dialog box up with an update channel.
You want to try to zoom in on that for you?
You can.
While that's thinking.
You might need to turn accessibility on to do
Yep.
that.
So, well, we're doing that, so keep talking.
I think we need to connect to the internet. That's why it's not being happy.
Oh, it's not on the internet. You mean internet? You need internet to do web applications? Connect to Scott's iPhone.
That would work.
Do you remember this password?
Yes.
You do? All right, let's try that again.
You remember the password?
Uh,
I'm not going to say it.
well, no, don't say it. People will be here.
Just get your notes.
It looks like you saved the password last time. Oh, there you go. Type it in. I forgot. So Visual Studio on the Mac, we want that to have parity with Visual Studio on Windows while still having that Visual Studio feel, but still being a Mac. It's a native Mac application. You can go ahead and get this application at visualstudio.com/free. And what he's showing is that you can go up into the corner of Visual Studio for Mac and you can say check for updates. Now you're on demo Wi-Fi.
I'm just going to go to my phone, which
Is that your phone or mine?
That's mine.
That would explain why there's two Scott's iPhones up here.
But anyways, whether this shows up or not, we can do the, here
It's okay.
it goes.
I'm going to hold it in the air. It'll get better signal.
There's basically what we call channels here. There's stable and there's preview. If you want to try the previews, all you have to do is switch to the preview channel and press update, and it will go and grab the build of VS that I'm using today. So there is a version of VS for Mac that will work today for Blazor applications.
Yeah, sorry, we can't get a signal.
So we don't need the internet for this anyway. So
All right.
we'll load the Blazor app up in VS for Mac. And just to show it is real here, I've got a breakpoint. Go scroll, zoom.
Yes, right.
We have a breakpoint on the count here. Just run that app, Scott.
Okay. Bloop.
And this is Blazor on a Mac in VS for Mac.
Oh, I just hit that button.
Breakpoints hit.
Breakpoint, locals, watch windows, call stack.
Everything just works.
So in that case, there's zero JavaScript, but you get that feeling of a JavaScript SPA, a single-page application running on any browser. It's not, doesn't need anything that doesn't have WebSockets, which is basically everything but IE6. If you're using IE6, I don't know why you.
Can you zoom back out?
You zoom by hitting Control and pulling back.
And so here's your Blazor SPA type application, all running on the Mac.
Can we open up that one there? Can we look at fetch data? So if you look at fetch data, this is a really interesting one here.
You should show the size of this in the debugger tools too.
I don't know how to. This Mac has that weird thing along the top that's like some kind of a.
Yeah, press that.
Yeah, that's exactly what I meant to do. Thank you. No, not now. Like, I mean, maybe later. Okay, so hang on. You push the touchy bar thing.
No, you press the function button.
Okay.
And you press the
push
F12.
the thing.
But you've already got the
What's a touchy? What a trash kind of thing. What the hell? All right, forget that.
Forget that.
What is the touch bar thing? This is so obnoxious. You can click it? Where, Mac people? I'm pushing F12. Oh, I don't have developer mode turned on?
Yeah, you don't. Don't worry about it.
Oh, well, crap. What I wanted to show, sorry, was under, bloop, 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 zoom in, there we go, was this. Take a look at that. This is not a very big thing. It's like 200K. It's really, really small. But notice how we've got that if-else statement there where it says if forecast equals null, then just have this HTML, otherwise it's this table. And if you go and look at that code, what we're doing is just some C#, making a call to a forecast API using HTTP, the exact same kind of code that you were doing before. Await, overrides, async, and tasks, stuff that you're used to. It's extremely familiar to use Blazor.
All formatted the same way you would expect on the PC, on the Mac, so Mac support now available. One more quick Blazor demo. I've got just a default Blazor app, and there's a community NuGet package called Blazor PWA. What's a PWA, Scott?
Portable web application.
So let's add this to my application.
Or pretty web application. PYT.
So this is a Blazor client application. So this is using WebAssembly to run on the client. I've added a Blazor PWA package.
Okay.
And now what's interesting here is let's go look under www.root.
I think I know what you're going to do.
And let's build
you
the
follow what he's
application.
doing here? A portable web application is an application that can work offline. It has all of its things brought down in a manifest, and you'll go and run applications like that. It's kind of like between Electron and a full native app. When you go to an application in like the new Edge, there's a little plus sign at the top that says install this app, and that app can then have an icon in your taskbar. You can click on it, it'll come up with a nice clean Chrome.
Look what has happened to my www.root folder. After adding that package, I've now got a manifest.
See, now the manifest
I've got
is there.
the service worker register.js, and some icons.
Portable web apps are an internet thing, not a Microsoft thing. This is a standard thing. You can actually take your existing websites, like I took my podcast website and turned it into a PWA as well. And you can go there, and if your browser supports it, like Chrome or Edge, you can go and see that plus and then install the web app as an app. So you can take now Blazor applications that run that stuff on the client side and turn them into local applications.
So I'm going to run this app.
Oh,
And
see,
something
look on the right.
new's going to happen. Well, look down here too.
Oh, you got that? So there's two things. See, it says add to your home screen, and in the upper right-hand corner, there's the plus next to the star. Look, install app. What? Now look, see how it's got that Chrome around it? The Chrome is gone, the address bar is ground, and now that can be an app, in quotes.
Look at my desktop.
Oh, it's on the desktop too?
I've got an icon on the desktop.
That's
If I go to my start menu,
fancy. Good job.
take any ASP.NET Web application, put it into Blazor,
Yep.
turn it into a desktop application. You can be anywhere.
So we're going to be putting out guidance and architecture documents as well as some books on if you have an existing web forms app that you can maybe think about moving it to Blazor. It's not a straight move because it's from an entirely different 10-year-old component model to a new one, but the concepts are very familiar. So if you are an existing web forms person, there will be a lot of formal guidance on how you can move your web forms stuff over to Blazor. It will feel very comfortable. The events will be the same. You'll never have to think about any JavaScript, and you get the bonus of being able to go and install them as web apps, which is really great and a good way to save and reuse a lot of code.
So we have about 20 minutes left, Scott.
All right, we'll make sure I get my time.
And I want to make sure you get your time, so I'm going to try to go fast on this one. So ML.NET, we shipped ML.NET early this year, version 1.0, and we had a cool tool called Model Builder.
Okay, what are you on here?
We're on this one,
You're
slide.
on that slide, okay.
Model Builder, and the idea behind Model Builder is it writes the model for you. You basically give it some data, and it does some stuff for you. I don't know who that was.
When you have 5 computers and then the USB thing says something got unplugged, that means something bad's going to happen.
So what I'm going to do is I'm going to go back to a desktop application. Let's go back to me.
Okay, you're on 6.
And what I want to do here is I want to do image detection. I want to be able to look at some images and have ML.NET tell me what that image is. So I'm going to right-click on my desktop application, and I'm going to click Add Machine Learning.
That's hilarious. That's exactly what I did to my LinkedIn. I just right-clicked and I said Add Machine Learning, and I'm getting all these job offers.
And I'm going to click Image Classification. And the way image classification works is you have to you have to train it. So it needs a folder. And if you look at my desktop, I've got this folder called Weather. And inside of it, I've got some cloudy pictures. I've got some rainy pictures, and so on. And so what I'm going to do in VS is I'm going to say, for that folder, I want to go to the desktop, and let's grab some weather here, and give it those folders. And you'll see that ML.NET went and figured out what those are. There's my cloudy, my rainy, my sunny, shiny.
It picked up the tag from the folder name.
From the folder name. Now, what's really new here is when I click train, it used to be that the only way we could actually train stuff was on your local machine. And imagine if you have thousands of images. You're going to watch the fan come on and melt your machine for the next couple of days while it does this. And so the cool feature we're announcing today is I can now train in Azure using Azure ML. So I can set up an environment. And I've already got one set up here.
And the importance of this is the 80-20 rule. You can get 80% accuracy in 20% of the time, but it's that last 20%. You saw us do that in the developer keynote where we could go and get something mostly right, but that last 10, 15%, that's where you throw the power of the cloud at it. So you do your prototypes locally, and then when it comes time to train on gigabytes, you throw it up into the cloud.
And I could put a crazy number in there, like I want to train for a whole bunch of seconds.
I don't know how many that is. It's a lot.
Neither do I.
Yeah.
So I'll start there.
The heat death of the sun in the future.
And I'll click Start Training. And you're going to see that now it's going to go basically upload those images to the cloud and start running stuff. You can see stuff is scrolling here. You can see starting AutoML in the workspace image training. So we're copying stuff up to the cloud.
Okay.
I'm not going to wait for this to finish. That's 5 minutes of stuff. Give me a link that I can go click on that will actually show me the work in progress of this happening up in the cloud.
Cool.
But let's not do that. Let's
actually see what the weather is, because we're here and I haven't seen the sky in 3 days.
Yeah, it's Scott was telling me earlier, just look up, and I'm like, well, I see lights.
I don't know what city I'm in.
And so what I'm going to do is I actually happen to have another version of this particular application right here.
So what we're going to do here is we're going to actually use the power of the cloud itself and Microsoft's latest runtime to tell you whether it's raining or not.
Now, what's cool here is what you're going to notice is if I let that other process finish, when it's done, it's going to go drop this model project into my application that contains consume code that we wrote for you. It contains the model. So all you got to do is run this wizard. It puts this project in. You reference the project.
And you can go and train that locally in a couple of minutes and then build your app around it. And then you can run that model for as long as you want and then just update the model.zip file and your existing consumption code works.
Here is the consumption code.
Let's go ahead and take off the selection and look at that. That's really it.
I new up a model input. I give it a path to the image that I want to actually analyze.
Yep.
And I tell it to go and predict that for me.
All right, do it live.
So let's do it.
The font is
Thank you, Bree.
retro.
And so I have some test images here. And then all I've got to do here is basically drag this over here.
Nice.
And it's
Cool.
sunny outside. Let's try some clouds.
Show me this science fiction picture of Seattle here where they've photoshopped out the rain.
It's cloudy outside. And I think this one is going to be sunny. But you can see that I can now take thousands of images, train them in the cloud. It'll build the model, download it back to my VS, stick it right in my project.
Is that
I'm ready
actually
to
a
go.
WinForms app too?
It's a WinForms app.
So that's the other thing. Think about your existing apps, WinForms, WPF, or whatever, and how you could potentially make them smarter, make them do more interesting things by harnessing this stuff. And then that model is a local model in that case. So once the model's been trained, that weather detection could be offline.
Yeah.
You would not need to talk to the cloud to do that
And
work.
so as we said, ML.NET 1.4 is out now, and it contains the new model builder for doing the image classification.
All right.
And
That
I'll
was
hand
that
it
demo.
back to you.
Magical. IoT. IoT I'm very, very excited about. This is the idea that I could go and support a Raspberry Pi and other devices. There's in fact a namespace now, system.devices.gpio, general purpose input output, and it allows you to do really cool stuff. Remember how I said I want to be able to do C# anywhere. I want to be able to do C# in a Windows Forms app or Web Forms app or a watch or Android. What we've got here is a Raspberry Pi running .NET talking to the same weather service that we were doing before. And what we've got is 4 32 by 32 displays in a matrix, and those are being pulse width, PWM, pulse, I have braces, pulse width modulation on each individual pixel. So there's a lot of interesting work going on there, but all the code is written entirely in C# by our friend Jose and Richard Lander, who created the app around it. So we've got a driver for that, the ability to talk to sensors, to the cloud, to then write to that display, whatever device you want. They just bought these online. You can go to Adafruit or wherever and buy these things. You can get involved and create one of the drivers for these by looking at system.device.gpio, which is up on GitHub. And the best part is, if you've got a Raspberry Pi at home and you're a .NET person, do you know that Docker works great on a Raspberry Pi? It's actually the fastest way to get up and running. You can go and run Docker on your Raspberry Pi, give it access, and then run hardware devices like this in a container on a Pi running .NET Core 3, which is just scrumptious. Isn't that cool? I'm a fan. Make sure that you take a look at that stuff. Okay? So let's talk about something.
You got one more slide there.
Yeah, I got this slide here. Now, this is an announcement. This is super interesting. What we're going to show you here is Jupyter Notebooks with .NET. You may not be familiar, but I'm going to walk you through it. This supports both C# and F#. Visualization support. You can use ML and Apache Spark to do many, many hundreds of gigabytes of analysis. And it ships in a thing called Azure Synapse. So let me show you why this is powerful and interesting and why you should care about it. You might be familiar with a thing that we did a little while back called try.net. So if you head over to the .NET website, it's a dot.net or .net.microsoft.com. And when you're learning about .NET, we gave you the ability to go and write the code in the browser. And this started out as a way where we would then post that code over to the back end, and we had containers that would go and run the code, and then the result would come back. We can also go and do that with Blazor, and that work can happen in the browser. But the folks that created this, the Try.net, Maria and her team, and all the folks on the Try.net team, put that code up on GitHub. You can go and see that at .net/try on GitHub. And it's gotten more and more interesting as the ability to arbitrarily run .NET code at scale starts to become interesting. So then they created an interactive documentation runner and builder. Remember we talked about global tools with the HTTP REPL. You can go and install this. If you have .NET now, you can go in and say .NET tool install, .NET try. All the details are up on the README on the .NET Try repository. And what's cool about that is you can make your own. So you would be able to go do something like this. You get the Monaco editor inside here automatically. And notice where we are here. We're on localhost because what I've done is I've ran at the command line .NET Try, which is a global tool. In this case, I just said demo. It starts up on localhost, and it gives you everything that you need to go and have the ability to read and create interactive documentation. So I'm in a folder there, and the folder is, in this case, I think I went over to here, and I'm sitting in Try.net samples/beginners, okay? Now look what's in this folder. It's not a bunch of ASP.NET pages. It's not a bunch of HTML. It's not even an app. It's markdown files. So think about that. What if you could go and put in C# in a markdown file, and then it would show up like this? So then you could go and teach computer science in the browser locally, hit run, and the code runs. So then folks said, well, that looks a lot like Jupyter Notebooks. Jupyter is a thing that Python and, is it Rust? R, Python, R, and Julia. This is a electric paper kind of a thing. Jupyter Notebooks allow you to go and run these things in the cloud. But what we've got here is people have been looking at this and then creating their own documentation. The folks at Poly have gone and done this. If you have an open source project, you can create interactive documentation. But the Try.net tool can then be installed, and you can register that kernel, that .NET runner with Jupyter that I've installed on my machine. I went and installed a thing called Anaconda. And Anaconda is like a joke because it's like Python and Anaconda, and they're all like snakes. So Anaconda installed all this stuff on my machine, and I went and I ran this kernel. Let's see. Oh, it looks like it shut down. Oh, it is running. So I go and I say Jupyter Lab, and I run the kernel. It's running localhost, okay? So check this out. I'm inside of a localhost running Jupyter. I've got a launcher that has C# and F# side by side with Python. And then I'm in this electric paper world, and I hit Shift Enter on each cell, and I'm running C# in a Jupyter notebook. Isn't that cool? So that's interesting. Yeah. But you might be thinking, well, why would I want to do that? Well, what if I wanted to go and actually ask a lot of interesting questions about a lot of interesting data? I can actually bring in my own NuGet packages. So you see here we're bringing OctaKit in from GitHub and Node at time. Those are now being installed. Boom, done. I'm going to go and create a GitHub public client. I'm just hitting Shift Enter, and I'm going to query the request and pull data out of the GitHub API. You see that star right there? That star means that it's running. That's a Jupyter thing. And because we've registered the .NET interactive kernel with Jupyter, that is running in .NET. There you go, it's done. Now we're going to go and do some link queries, because I know how to do this already. And then, see where it says display line chart? I get a free interactive line chart. I can do that in C# or in F#. There's a scatter plot or a line chart that I'm running, and then I can modify these things and run them again, and they update. So it's that Jupyter Notebook experience with the interactive .NET kernel. It's pretty fantastic. In this case, it's running entirely on my local machine.
Right. So what's cool is you don't have to run on the local machine. So I'm like, what if I don't want to install all that stuff on my machine, Scott?
Okay.
You can go to the try.net GitHub site, and we're going to clean that up today so it'll be easier to find where I'm going to be. But there's a place where I can do a right-click and launch something called Binder. And in this particular case, here we have basically Jupyter Notebooks running in my browser with nothing on my machine. We have a container running up in the cloud that runs this. And so I just have to have a browser. If I want to go and run some C#, all I've got to do is come over here, click C#.
So in this case, he's got the power of the cloud, just like we saw with that machine learning where we did some work locally and then we moved that work up into the cloud. By going into Binder and warming up that container, he can go and do those plots and charts and things entirely here.
Run them inside of this, and we are super short on time. I want to show one more quick thing as well. Is we just introduced a new service in Azure called Synapse. And Synapse is a data warehouse and a place to run Apache Spark, which is a huge engine for processing large amounts of data inside of Azure. And what you're going to notice over here is in Synapse, it also has a Jupyter Notebook experience as well.
Right, and I noticed that language says .NET Spark right there.
.NET Spark is right there.
F#, yeah.
And so I can go run, we announced at Build, Apache Spark support for C#. And here it is. I'll actually show the version that's already running.
How big of data can you do? Like my machine only has so big of a hard drive. You moved into the cloud.
We used to say that when you want to have more than 50 terabytes of data, you've outgrown a SQL server and you might want to go to something like Apache Spark.
50 terabytes.
Yes.
Okay, that's a lot.
Lots of data.
Yeah.
And the cool thing about this tech is I'm just showing you the output of it because I want to go back to slides real quick.
Sure.
But you can run all these. The cool thing about Synapse is with Synapse, it doesn't cost you a lot because what happens is it's only running any of the Apache Spark stuff while you're in the Synapse experience. So as soon as I close my browser out, all of it goes away and I'm not being charged for it. So it's a great way to experiment with C# and with big data. If we had tons of time, we would show the actual data set we have here and show some of the results. But I do want to pop back to a couple slides.
And there's going to be a blog post live on that. I'm going to be blogging about it later this week. So if you're interested in it for interactive documentation or for massive amounts of data, .NET runs in Jupyter Notebooks right now with the language that makes you happy.
So we want to close really quick and talk about .NET 5. We just shipped .NET 3.0 about 5 weeks ago. .NET 3.1 LTS will ship in another month or so. And then what's the next .NET? The next .NET we're thinking is .NET 5. We were kind of in a place where we had .NET Framework 4.8, .NET Core 3. It would be confusing to have a .NET Core 4 and a .NET Framework 4.8, so we thought we would just skip the version and go to 5. And what we also would do is take Framework, Mono, and Core, take the best of all of those, put them into one framework called .NET 5, and we'd give you the ability to run both apps like we do today, and an improved version of that single exe where we actually take your app, compile it into a single exe, pre-compile it, all those things so it's super fast, kind of the native style of that. You can run either JIT or native, one base class library, .NET standard across all of them, and our platform starts to look something like this. All the apps, all the developer tools, all one platform. I do want to talk about this. One of the feedback I've gotten from people is like, oh no, you're turning it back into like .NET Framework, you're going to make it huge and big and all these things again. If you actually look at .NET Core 3 on disk, it does not work that way. If you build an ASP.NET Core application, you are not bringing in the desktop DLLs or any of those things. If you're building a desktop application, you're not bringing in all the ASP.NET DLLs and all that kind of stuff. So we've re-engineered .NET Core so it is pay for play. You only get what you use. So it is not like .NET Framework. You have to have the entire framework on your disk at any given point. If I want to have a server run ASP.NET, I don't have to have the desktop DLLs on that server at all.
You only ship what you use.
Right. And so this is .NET 5 that would ship on this schedule. So we also want to make our schedule for .NET very easy for customers to understand. We don't want to ship at random times. We want to make it easy for people to understand what's coming. And so you can see we shipped .NET Core 3 in September. .NET Core 3.1 is November, but it's going to slip 3 days because it's going to align to Visual Studio 2019 16.4. So it'll be early December is when that's going to ship. And then every year in November, we're going to have a new release, with .NET 5 being next year, .NET 6 being the LTS build the year after, and so on and so on. So it should be easy for you to understand when the next .NET's coming, and we'll make sure the roadmaps and stuff are very public in GitHub and on our websites as well. Our closing message would be download .NET Core 3 today, and really one of the messages for me from the .NET team is if you're going to build a brand new application, you should build it with .NET Core. If you have existing applications on .NET Framework and you're not modifying them, you should leave them on .NET Framework. .NET Framework is not going away. I have a team in Redmond working on it right now. And basically, it's kind of aligned with Windows, which means as long as we're shipping on Windows, we'll be shipping a .NET Framework. So there's no rush to move applications off of .NET Framework to .NET Core, but new apps should be .NET Core. So with that, I think thank you very much. I hope we showed you a lot of demos and a lot of cool stuff.